Let's do this example. So what is the what form does it take if you plug in the limit? Limit x tends to 0. Sine 5 times 0 is sine 0, right? That will be 0 over 9 times 0 is 0. So basically it is taking 0 over 0 form. So we are okay to use L'Hopital's rule. So how do I use the L'Hopital's rule? Equals to, let me write L'Hopital's rule there. Find the derivative of the top. It is like sine u, right? You see that? It is like sine u. What is the derivative of sine u? It is like cosine. Let me erase that. It is like cosine u is 9x, 5x. Cosine u times derivative of u is just 5 over, let's do the derivative of 9x is just 9, right? Because we are finding the derivative of the top separately, derivative of the bottom separately, and then plug in the limit. Let's plug in the limit and see. So, oh, I forgot to write the limit. Limit x tends to 0. If you plug in 0 here, what do you get? Cosine 5 times 0 is cosine 0 is 1, right? So 5 times 1 is 5 over just 9. That is the final answer. So the limit becomes very easy. But you cannot use L'Hopital's rule for all the limits. Only the limit that takes either 0 over 0 or infinity over infinity or one of these forms can be used, can be found by using the L'Hopital's rule. Okay, let's do this one. If you plug in the limit directly, what do you get? You will get 1 minus 0 square is 1 minus 0 is root 1. That is just 1 minus 1 is 0 over 0. So we can use L'Hopital's rule here too. You see that? So so what do you get then? So we need to find out the derivative of the top, right? So let's use L'Hopital's rule. So equals to limit x tends to 0. What is the derivative of that? You will do, let me do like this, 1 minus x squared to the 1/2. But let me write down the prime for that. You can do minus 1 and then prime, divide by x and then prime, right? What is the derivative of the top? It is like, for the first, this parenthesis, the things inside the parenthesis, you can take that as u. You see that? This you can take that as u. This thing can be considered as u. So u to the 1/2. So what is the derivative of u to the 1/2? So the u to the 1/2 will be 1/2 u to the 1/2 minus 1 times the u prime minus the derivative of 1 is 0. Divide by 1. Okay, let's plug in the value. Limit x tends to 0, 1/2 u is 1 minus x squared to the negative 1/2, because 1/2 minus 1 is negative 1/2 times the derivative of u is how much? Derivative of 1 is 0 and then minus derivative of x squared is 2x. So that is negative 2x over just 1. So you don't have to write that 1 basically, right? So let us further simplify this, because this has negative 1/2 in the exponent. I want to move that, but before that I want to cancel that 2 with 2, because they are the same number in the product form, right? So 2 and divide by 2 is basically 1. You can think that way. You see that? Okay, let us talk about how it will look like. It will look like this: negative x, because there is 1, and then times negative x, because 2 gone already, over this goes to the bottom with positive 1/2 exponent, but I want to write that as 1 minus x squared. Let me plug in the limit there. What do you get? If you plug in the limit, you will get negative 0 over root under 1 minus 0, right? So negative 0 over root under 1, that is basically 0. You see that? So the answer is 0, the limit is 0. So without the L'Hopital's rule, it was almost impossible to, I mean, you can do the conjugate, but that takes a long time, right? So some of the problems, you need to use L'Hopital's rule to find out limit. Otherwise, it will be very complicated. Okay, let us do this example. Find limit x tends to 1, x to the 10 minus 1 over x squared minus 1. Let's plug in 1. 1 to the 10 is 1 minus 1 is 0 over 0 again. So it takes we can use the L'Hopital's form, right? I mean, it takes the indeterminate form, so we need to use the L'Hopital's rule or L'Hopital's formula there. You understand? Okay, so let us find out the derivative. Let us use the L'Hopital's rule here. So what I want to do here is write down L'Hopital's rule. Let's use that. Equals to limit x tends to 1, okay, what is the derivative of the top? It is 10x to the 9 minus 0, because the derivative of 1 is 0. This will be 2x to the 2 minus 1 is 1, 1 and then minus 0. So that is basically 10x to the 9 over 2x. So can you simplify this? I mean, you can plug in limit x tends to 1. That's not a problem, because you don't get 0 over 0 anymore. Okay. So what do you get? You get 10 times 1 over 2 times 1, right? This is basically 5, because 10 times 1 is 2. 10 over 2 is 5. So that is the final answer. Okay, guys. So we will see more examples on how to use L'Hopital's rule. Let us see another example. On this example, you see that you want to find out the limit x tends to infinity. This is the difference you see, right? So far you were seeing limit x tends to 0 or 1 or a number there, but now it is infinity. If you plug in the limit right away, what do you get? E to the infinity square is e to the infinity is infinity, big number, divided by 7 minus infinity cube is negative infinity, right? So it will be infinity over infinity, but it is negative. That's fine. This is still indeterminate form. So what do you do next is you want to find out the derivative. You want to use the L'Hopital's rule, find the derivative of the top and find the derivative of the bottom separately. Okay, so let's do that. Let me write L'Hopital's rule. Okay, so that is the derivative. It is like e to the u. You see that? It is like u. This is like u. So it is e to the limit. Let me write down the limit as well. X tends to infinity. E to the u times u prime over the derivative of that thing is 0 minus 3x squared, right? So let me plug the value of u, e to the this is x squared times u prime is 2x, right? Divide by, what do you get? 3x square. You see that? So can you cancel something? Yeah, of course. So that x will cancel with that one of the x there, right? So what is left actually is basically, this is what it looks like, 2 e to the x square divided by 3x. Now if you plug in the limit again, what do you get? Limit x tends to infinity will give you in e to the infinity over infinity. So it is still infinity over infinity. You see that? That is still infinity over infinity form. So we need to use the L'Hopital's rule again one more time. So this is equals to L'Hopital's rule. Okay, I want to use that L'Hopital's rule. I want to write down limit x tends to infinity. Again, you can take this as e to the u, right? There is 2 on the front, but there is e to the u. So you find out the derivative of the top and the derivative of the bottom. So let me write 2 and then e to the u times the u prime divided by 3 times the derivative of x is 1. Okay, let me plug in the values of u and u prime. So 2 e to the x square times, what is u prime is 2x again, 2x divided by 3. So what is the simplified form? It is 4x e to the x square divided by 3, right? Now let's plug in the limit. Do you still get the indeterminate form or not? So let's see that. So if you plug in that x is infinity, it is infinity times e to the infinity square, that is infinity. So it's a huge number, divided by 3 is still a big number, right? So basically, so the limit x tends to infinity, 4x e to the x square over 3 equals to basically infinity. That is the final answer, right? So let us do another example. This has also x tends to infinity. You have e to the 3x minus 5 over 5x. If you plug in the limit, what do you get? You will get 3 times infinity is infinity minus 5 is infinity. E to the infinity is infinity over 5 times infinity is infinity, right? You are just plugging in x tends to infinity there. So you can use the L'Hopital's rule. So how do I use the L'Hopital's rule? So let's write down L'Hopital's rule equals to find the derivative of that. So you can think this is like a u, right? So what is the derivative of the top? L'Hopital's rule says that you can find the derivative of the top separately, derivative of the bottom separately, right? So it is e to the u times the u prime over 5 times 1, right? So e to the 3x minus 5 times 3, because the derivative of u prime is 3 times 1 minus 0, right? Just 3 divided by 5. What do you get? Now take the limit. Oh, I forgot to write the limit here. Limit x tends to infinity. So what do you get? If you plug in the limit there, you will get e to the infinity. 3 to the infinity is infinity minus 5. If you subtract a small number from a huge number, that number will be still huge. So I write still infinity when I plug in x tends to infinity, and then multiply by 3 and minus 5, and then times 3 is also infinity, over 5 is infinity. So basically the answer is infinity for this problem too.